some helpful hints for you MOS observers. I'll first note that there is a spectral visualization tool, which is a standalone tool that was developed to help to visualize the source spectra from the various areas of the microshutter array on the detectors as they would look on the detectors. It's called MSA Viz. It was generated by a colleague of mine in the NIRSpec instrument team. I would suggest using this to not only get an image of what your spectra will look like, but also you can download a report indicating the wavelength cutoffs for each of the sources that are observed. In the figure that I've generated here, there's a very simplistic set of source spectra that are generated for spectral lengths of like 20 shutters seen at various locations in the microshutter array. I'm demonstrating basically that you can see that the wavelengths, especially for the prism as shown here, there are, depending on where it's located in the MSA, there could be a considerable loss of wavelengths for prism spectra. The instructions are found in the JDocs for the NIRSpec JDocs, which I've shown you a link for here, and you can read more about that tool and the use of that tool there. At another grading, you can see that the spectra, of course, are pictured longer. The tilt is a little different than for the prism, and then the wavelengths lost are, of course, going to be different depending on the grading selected. And then finally, another grading here showing the high-resolution grading spectra. Okay, so there are some takeaway points from this video that I'd like you to have. And that is, number one, that there is a new version of MPT that we've developed. It's been released now for cycle 1 for the call for proposals. It's easier to use, it's more intuitive and discoverable, and it is more lightweight than the previous one was. You'll need high precision relative astrometry for your input catalog. So you need to generate this catalog up front. You can also use the simulated catalog for your phase 1 MOS proposal if you are also considering putting in NIRCam observations for pre-imaging for the NIRSpec component of your program. Then you will have to probably generate a simulated catalog to get a realistic idea of what the efficiency of plans are and the overheads that are going to be involved. The relative astrometry should be 5 to 15 milliarc seconds to make the best use of the MSA planning tool parameters and the tweaks that we provide there. But up to 40 milliarc seconds if you're considering science of extended objects, for example. MOS is one of the very few observing modes in JWST that will have to follow this multi-step planning process, so it is different than other modes on James Webb. The programs require an aperture position angle, so you can explore that aperture position angle with feasible angles for your source pointing, then during the runs that you do of the MSA planning tool. But note that an observing angle will be assigned by STFCI for your MOS programs. This is what requires a phase 2 update or a program update for your MOS programs. NIRSpec overheads for MOS are considerable, so it's worthwhile using MPT to have a good estimate of what those overheads will be. You can use the MSA Viz tool, which I just spoke about, to verify that your wavelengths of interest will be observed. And you can also use the NIRSpec observation visualization tool, which I talked about earlier in the talk, to visualize your NIRCam pre-imaging relative to your MOS observations if you intend to get NIRCam pre-imaging in your program. And then also, you need to know that you need to dither quite a bit, and it helps to both improve sampling, do background subtraction, and then wavelength coverage, improve the wavelength coverage, and also mitigate light leakage. Some other helpful hints. You might want to order the catalog by your target weights. That's one thing you can do. You don't necessarily need to do that. If you elect to use weights, the catalog will be ordered for you. It will try to put in the highest weight sources into the MSA configurations in your plan. Only the weights of the primaries matter for the pointing selection. However, the filler weights do matter in collecting a total weight for your plans. So you can add fillers to maximize the efficiency or the multiplexing on the MSA configuration. And additionally, we have this new feature called Make Use of Partially Observed Sources when dithering. And you can do that in the planner. And what that will do is it will attempt to place more of your primary sources into the MSA configuration, even though they can't be tracked through all of the dithers. It will do this in the most optimal way that it can. It will look for sources that will be in all but one of the major dither points that you've specified. The sources will be present at each of the nodes in any given dither point. So that's something to keep in mind. That's another way to maximize your multiplexing in the MSA. If the feasibility windows for your source are large, you will want to test several aperture position angles, because most likely, the STSCI assignment of your angle may not be one that you exactly planned for. So you should test many. And only if you really need to should you add an orient special requirement. And that special requirement should have a minimum range of 20 or 30 degrees in order to allow for some flexibility of planning your program on the long-range plan. If you're using high-res gratings, you want to try to get your sources mostly in the left MSA quadrants. And that's basically to avoid any detector cutoffs at the red end. You can use the Aladdin field of view to show the position of your NIRCam parallels with respect to your NIRSpec microshutter observations. And that's something you can do just by putting an image in Aladdin and then overplotting the footprints of both the NIRSpec and the NIRCam parallels. Your catalog should be complete. To be able to check for contaminants, you can overlay the complete catalog onto any MSA configuration of one of the exposures, for example, and you can visualize whether there are contaminants that are present in the slits that you have planned for your primary and filler sources. And then finally, the MSA configuration editor is available at the observation level in the MOS program. And the MSA configuration editor is started by selecting the column at the very end of one of the tables there. And you can actually manipulate the shutters by clicking them on and off in the MSA configuration editor pop-up window that happens. It looks very much like the MSA shutter view, which I demonstrated. The configuration editor is where you can make modifications to the configurations in your plans if needed. Thank you very much for listening to this video. I hope you found it useful and that you will be planning your MOS observations in the very next cycle. Thank you.